Okay, you should have your note-taking guide out to lesson 4.4. I'm going to talk you through the lesson while you fill out your notes. Let's try it, folks. Tomorrow we're going to talk about slope and rate of change. The slope, you guys should have learned about last year, is a ratio of rise, which is the vertical change, compared to run, which is the horizontal change. And that is a comparison between any 2 points on a line. Emphasize any 2 points, because the line should be straight. Sorry, my board's not very well aligned. Now, you should remember from last year that slope is always shown using the letter M. No reason for that, just slope is known as M. Now, your other vocab term is rate of change. Rate of change is exactly what slope was. It is comparing two values, rise compared to run, but it's in other quantities. So this is what we call slope in story problems. All right, let's take a look at how to find slope. That's the wrong page. Sorry about that. All right, this should be the first thing that you see. Slope is of a non-vertical, that means not straight up and down line, passing through 2 points, and here's an ordered pair for those 2 points, is comparing the rise to the run. Now, rise over run, you should recognize that. This is going to be your big formula for today. Notice what we're doing in this formula. You are subtracting the y values and subtracting the x values. The difference in your y values is your numerator. The difference in your x values becomes the denominator. And that creates your slope. In our picture here, you see that here is a point on the graph, and here is a point on the graph. We have to figure out how much does it rise. What's the distance between here and here? And that becomes your numerator. That becomes your change in y. And then we figure out how much does it move over. There's your run, and it becomes your change in x, which creates our fraction for slope. Now, if they give you 2 points, you should use this formula. If they give you a picture, the picture is by far the easiest, because all I need to know is our rise compared to our run. So I'm going to start with my point and figure out how far I have to go up. Well, I need to go up to there. That's 1, 2, 3, going up. Now my run, I need to go from here all the way over to here. That's 1, 2, 3, 4. Well, I compare my rise to my run, and my slope should be 3 compared to 4. Let's check out our answer using the ordered pairs. I have the first ordered pair, -1 and 2, where -1 is my x value, 2 is my y value. 3 and 5, where 3 is my x and 5 is my y. You need to make sure that you start with the same ordered pair every time. It doesn't matter which one, but let's start with those y values. I take 5 minus the 2, and then I take 3 minus, now watch your signs, -1. Guys, watch. 5 minus 2 gives us a numerator 3. 3 minus -1 gives us a denominator of 4. So our slope is 3/4. We like fractions now. So if they've given you 2 ordered pairs, all we need to do is find the difference between those ordered pairs. Here's a y value, and here's a y value, and I need to subtract them. -2 minus 3, and I'm going to put that over the difference of my x values. Make sure that you start with the same ordered pair each time. I started with the -2 from the second ordered pair, so I need to start with the 5 from the second ordered pair, minus, watch your signs, -6. And that equals -5 over 11. And I cannot reduce that fraction, so my slope is -5/11, and it is that. If you are looking at a graph, it is by far easier to count the slope on the graph. In example 2, take a look at it. My graph is this horizontal line. Well, from point to point, how far do you rise? You don't rise at all. But my run is 1, 2, 3, 4, 5, 6. Well, what's 0 over 6? Slope here should be 0. We can test that out with our points. My y-coordinates are 5 minus 5, and I subtract -4, sorry book, minus 2. That's 0 over -6, which also gives us 0. So if the line is horizontal, the slope is 0. Now what about over here with this vertical line? Ooh, my board is not aligned. In this vertical line, how much do we rise? 1, 2, 3, 4, 5. We rise 5, and we run nowhere. If you type in your calculator 5 divided by 0, it's going to give you an error because we can never ever divide by 0. So if a line is vertical, the slope is not error. We say the slope is undefined. Yes, you need to use that terminology, undefined. Let's check that with our ordered pairs. My y values are 3 and -2, and 3 minus -2. And my x values are 4 minus 4. Notice the x values are the same. 5 over 0, and that's going to be undefined. A lot of people remember this as 0 in the numerator is okay, and 0 in the denominator is a no-go. So 0 in the numerator is okay, 0 in the denominator is a no-go. Rate of change is exactly like slope, where you need the change in y over the change in x, but now we have values and meaning behind them. So they want our rate of change to be comparing the change of cost to the change in time, because time is our x, cost is our y, and you can pick any 2 points. We can pick these 2 points if we want. So the change in cost, I go from $2.19 to $2.09. And I'm comparing that to day 5 to 3. Well, that is a difference of 10 cents in 2 days. And that means our constant rate of change is 5 cents. Ooh, that's not 5 cents, Miss Curran. Catch me on those. 5 cents. But because this has a label and a meaning behind it, we need that it's 5 cents, and we say per day. 5 cents per day. And this would be your answer. Your rate of change is 5 cents per day. It should be the exact same if we did the other one, because the difference between day 1 and day 3 is also 10 cents, and the difference is also 2 days. You'd get 5 cents per day again. Last example, they want you to find the rate of change again, but you need to figure out what is your x and what is your y. They want the rate of change in degrees Fahrenheit with respect to time. With respect to means as a function of time. So time is actually your input, and degrees is your output. So our change in y, 43 minus 38, and my change in x, 2 minus 0, that would give me, pardon my subtraction in my head, that would give me 5 over 2. And that change is 2.5 degrees per day, or I'm sorry, per hour, because that is our unit for time. So the change is 2 degrees per hour. As a standard rule of thumb, time is always your input, always, always. But that's how you would write your rate of change. You need a label with it every time. All right, that was our first attempt at listening to your notes. I probably went too fast, so please go back and pause at any time. Enjoy!